My name is Sergey Vishnevetsky. I'm Development Director of ODA, and I'd like to continue the, I would say, great presentation of Jeffrey about IFC and highlight the role of ODA in this process of IFC implementation, IFC development, and to promote this standard to the CAD industry. When we got survey result of our members a year ago, we were quite surprised that more than 60% of our members are interested in IFC toolkit from ODA. Why? Because it was strange for us because overall there are a number of solutions in the market. But after closer look to those solutions, it appears that those existing three groups, I mean open source toolkit, commercial toolkit, and private toolkits, has a lot of disadvantages. Open source toolkits usually provide IFC support on lower level and often not supported well. Commercial, very expensive and simultaneously don't provide appropriate level of functionality. Private are private, so we were not able to analyze those toolkits. Certainly, they support reading and writing of IFC functionality in some manner, but now we are talking about other level of IFC support. And it's ODA IFC SDK. It's toolkit provided as a general part of general membership. So it means that it's available without any additional expenses for you. And what's more, for more than 1,000 CAD and BIM software companies. And simultaneously, it's developed by a company who is working in this area for more than 20 years by the moment. And we are going to maintain this toolkit in the future. And I think that we are the only organization at the moment that is working at support for complete set of functionalities that is present in IFC. Well, the first is architecture of what we are doing of IFC toolkit. Orange and black blocks are implemented. The gray ones are in development yet, in progress yet. The same as IFC 5 is in progress on Building Smart, and therefore we are not providing that standard yet, and high-level functionality is in progress yet. But what we have at the moment? We have tight integration certainly with ODA technology stack. It means that all things that we are doing based on the kernel SDK and kernel functionality and is compatible with our visualization SDK, publishing SDK, can be easily exchanged with other formats. I mean, we'll see example later. Overall, the structure, I would say it's layered structure of our architecture. We have the data layer, based on the Express Schemas support provided by Building Smart. We have low-level early binding API for most popular formats of IFC. And also we implemented the late binding API that allows to work in common manner with different formats of IFC. Well, API. Certainly we provide API for step physical files. It's used not only for IFC, for step IGES, and we are going to support those formats in the future as well. And we provide API to working with those files, but its basic point just required to move forward. We implemented two levels of API, early binding API, late binding API that provide access to properties, model and all other data. About SDI mentioned here, overall there are two implementations, C++ SDI and two standards, C++ standard and C-style standard. But it appears in the market the C++ standard implementation is quite different from one vendor to other. So I would say it's usually variation of the standard. But from other side, C-style implementation, it was also a bit surprising for us, but it's widely used C-style implementation, and therefore will support. As beta version is already available, but we'll support it in a month or so, the C-style. So it make easier to move to IFC SDK from ODA from other type of from other toolkits. Express Schema compiler adds as all format is described with Express Schema. We made compiler and our classes are automatically generated. Low-level class automatically generated from schema definition. Implemented set of services classes, and supporting of new schemas, I think, will be quite easier for us. And overall, we checked already with some schemas that is under development by Building Smart, and we sure in this. At the moment, two main schemas are presented in the toolkit that is shipped out: IFC 2x3 and IFC 4. Certainly, on this video, you see the maybe not the main difference, but the visual difference about more wide using of B-Rep data in IFC 4. But we are supporting not only these geometry differences, but also the all properties and all new classes that are appears in the latest IFC format. Well, two API: early binding API, late binding API. Early binding API overall doesn't seem to be maybe very convenient to use, but all open source toolkit in the market have only such ones. Why? It's clear, because it's simpler. Just make generator, generate those classes, and after that, yeah, you can work with classes. But if you would like to save IFC 2x3 format, you should use one set of classes. If you want to save IFC 4 classes, you should use other set of classes. It may be not so convenient for development. But we are supporting, and this API, I mean early binding API, is also public, so everyone who uses such open source toolkit from our members, and they can easily switch from one free solution IFC that they are using at the moment to other professional free solution for members, existing members now. The next level we implemented is late binding API. It's higher level, and it allows to work with different format in common manner. And also this level of API is used further in geometry generation. So we are working in a similar way with both format. It needs to take into account that, for example, despite of many other formats, IFC has implicit geometry inside. So you should make additional processing to generate result geometry. For example, Boolean operations are not presented as a result inside the IFC file. You should make those Boolean operations to provide the final geometry for application. And we made this. And overall you see result also on the screen. And also this implementation, as I said, based on the late binding API, is compatible with IFC 5 with further IFC implementations as well. I'd like to say some words about Advanced B-Rep. The thing with Advanced B-Rep is that it's quite interesting feature, quite good feature that places it in IFC standard. And overall, in the standard, there is no limitation for using this feature. But to minimize efforts, all IFC toolkits providers or companies who are using this software to make conversion use this feature only for one point: to save proxy geometry. And we found one file, something like that using this in real chain for build the explicit geometry. It appears that no one other viewer is able to support this. So I mean, and this is quite similar situation with many other geometrical entities, that many vendors using very limited set of IFC abilities that are presented in the toolkit. I don't want to say that at the moment we support all abilities, and certainly we started from the part that is widely used in the market, but we are moving forward, and I think that, for example, such feature as Advanced B-Rep, we also provide better support for this feature in the future, and will be available, and that feature will be available for everyone. Other difference, and I think significant difference with any other IFC toolkits in the market, that usually if someone implement IFC toolkit, and for geometric entities support for conversion implicit geometry to explicit one, they use one choosed modeler, B-Rep modeler, Facet modeler, and overall you stack with one type of geometry. But we try to be open, and provide access for other modelers to IFC framework as well. For example, if you are using in your application ASYS modeler, Spatial ASYS modeler, or I don't know, Perisolid C3D modeler, you can make integration, and IFC support will be tightly connected not only with Open Design Alliance tools, but also with your application. At the moment, we provide implementation for two modelers supported in ODA, Facet modelers, you see example, and Solid modeler, and also the implementation for Spatial ASYS modeler, as it's mostly used by our members in their application. Facet modeler in the production stage, Solid modeler and Spatial modeler are under development yet, but we are quite close to provide the result with those modelers as well. You saw on this picture you saw the difference, I mean, between on small picture, but on other ones you could see the difference in the larger models as well. Well, the next things, again, unique. The next thing we started working is conversion. Conversion between IFC and other formats. Certainly, it's the usual functionality that everyone uses for IFC to convert their data to IFC, to load them back. But what's unique is that IFC toolkit providers simultaneously working at the conversion utility in conversion functionality as well. It means that, for example, in other case, you can download, you can buy IFC toolkit, you can try to use it, and after that, you find out that you first met some issues because no one even tried to use it before or try to use that functionality in this way and that way. But it's not the case for us. Starting working, by the way, we started working on IFC toolkit only 9 months ago, and therefore you see the result of work of 9 months. And together we started work on implementation. We started working on conversion tools to be sure that our toolkit is ready to use in commercial applications. Certainly, the first was conversion to the DWG. It's obvious for Open Design Alliance. Also, the other project was import for DWG architecture to the IFC to check the abilities, not only read but write functionality. This project is under development yet, but here presented initial results. Overall, as I said, that we worked for to be sure that this toolkit is ready to be using in commercial applications. And it's great that today we'll already see, after 9 months of work, examples of using this toolkit in real commercial application. But what's the next? Certainly, the first thing is general improvements. 9 months, it's not so long period of time, and general improvements, performance area, like multi-threading support and other ones are required. Documentation should be improved, examples additional should be provided for our users. Yeah, it's so. We are going also to support IFC XML, which is provided by Building Smart as a second standard file for saving this for IFC data, but it's not so popular as the physical file. But anyway, we'll provide it. Other interesting direction is to extend support of functionality provided by Building Smart. I mean, for example, model validation. And other important directions that we are working at, and I hope to see some result next year, is high-level API, and I think it will make easier to create valid IFC file than now. Well, so we have a lot of things to do, and we have a long way ahead. So, as conclusion, I think that Building Smart and Open Design Alliance partnership opens a new page of BIM interoperability with IFC. And the same as Building Smart provide BIM standard for the industry, Open Design Alliance put efforts to provide SDK that becomes a standard implementation for IFC data. So, and we hope you will check this result and use it in your application. Thank you.